science kids. So for the next 3 weeks, you have me for science. And I am teaching you about boats and buoyancy. Now buoyancy is made up of a couple different things. One of them being density, one of them being displacement. This week we're going to talk about density. How the density of the object that you're trying to float and how the density of the water affects how that thing floats. Next week we're going to talk about displacement. So in this week's video you're going to learn about this iron spike and this piece of styrofoam and why one floats and one doesn't. You're also going to make a couple of tinfoil boats, one that looks like a canoe and one that looks more like a rowboat. Your boats will be much smaller than this, but the same concept. And I guess we should start with our lesson now. Okay, so for the next 3 weeks in science, we're talking about boats and buoyancy. So before we get into boats and buoyancy, I want to talk about something important to boats, and that's floating, right? So I've got two things here today. I've got this iron spike, and I have this piece of styrofoam. Now, if I put these in water, what's going to happen? When we take the iron spike and we put it in the water, what does it do? If you predicted that it would sink, you're absolutely right. Look, it went right to the bottom of my water. If I put the styrofoam in the water, what's going to happen? If you predicted that the styrofoam would float, you're right, the styrofoam floats. So how come these two objects that are about the same size, one sinks and one floats? Great stuff. So when we talk about things that float and sink, part of the answer lies in something called density. Imagine that you have supersonic vision, and you can look into this iron spike, and you can see the tiny particles that make it up. All matter is made up of particles, whether it's an iron spike, a piece of styrofoam, or the air we breathe. In some things, like this iron spike, the molecules that make it up are really tight together. They're squished all tight together. And when we talk about that, that's density. It's really close, so it's really dense. In the styrofoam, the particles are farther apart. And the science word for that is we would say it's less dense. So styrofoam is less dense. The particles are farther apart. The iron spike is more dense. They're really tight together. So if something is less dense than water, meaning the particles are further apart than the particles in water, it'll float. If something is more dense, meaning the particles are really tight together, it's going to sink. All right, so what we learned is this iron spike sinks right away when you put it in water. And we said that's because it's very dense. That means the molecules in the iron spike are very, very close together. And we said something like styrofoam floats because it's not dense, because the molecules aren't very close together. So if you have your iron spike being very dense, which sinks, and you have your styrofoam being less dense, which floats, you could imagine that these might be the molecules of water. Not as close as the iron spike, but not as far apart as the styrofoam. So now, let's think about air. What's going to happen when I put some air into my tub of water? I'm going to use a straw, and I'm going to put air in the bottom. What's the air going to do? Did you see that? It all bubbled up. Air will always come to the top of water because air molecules are further apart than water, further apart than styrofoam. Right, pause. So I have this glass, and I'm going to put some water in it. Now I'm going to ask you the age-old question. Is this glass half full or half empty? Now think about your answer. And think about what happened to the air in the tub. It's a trick question. This glass is actually full. It's half full of water and half full of air. Air will always come to the top of water because air is much less dense than water. So if we imagine the molecules of air, they would be spread out much further than the molecules of water. So air is always on the top. So this glass is full. It's full of water and air. Okay, so far we've learned a little bit about things that sink and things that float and how density plays in. So now I'm thinking, I have this egg. This is a hard-boiled egg. And I wonder if it's going to sink or if it's going to float. So, what do you think? I'm going to add a little more water to my glass. And then I'm going to drop the egg in here. If it's more dense than the water, it's going to sink. If it's less dense than the water, it will float. Whoops! It sank right to the bottom. That means the egg is more dense than the water. But wonder if we can change the density of the water and make it more dense so this egg would float. What I'm going to do is I'm going to take some salt and I'm going to add the salt to the water. And what I'm doing when I do this, if you imagine that these are the molecules of the water and we're going to put some salt in there, can you see how the salt particles can go in between the water particles and make the water more dense? Salt water is more dense than regular water. That's why if you go to the ocean and you go swimming, you float a whole lot easier. So I'm going to just pour a bunch of salt into this water. We're going to try and make this like the ocean. And I've got to stir it up. Stir it, stir it, stir it. Now would be a good time to pause. All right, so I've added some salt to the water and I'm stirring it up. And basically what we're doing is we're going to change the density of the water. The molecules in the water that are far apart now have molecules of salt in between, which makes it more dense. Just like when you go to the ocean and you swim in the ocean, the water is more dense, so it holds you up easier. So now that the water is more dense, do you think the egg will float? Let's see. Look it! Do you notice the egg is floating? That means that the water is now more dense than the egg. We've changed the density of the water by adding the salt, and now the egg floats. It's like magic, only better because it's science. So for the hands-on portion of science for week 4, you have a Ziploc baggie in your box and it says week 4 science. And what you have in there is this template of a canoe and a rowboat. You have some foil and you have some cardboard. You're also going to need scissors and a marker. The first thing you're going to do is you're going to cut out your shapes. You can pause it. So once you've cut out your 2 shapes, you're going to lay them down on your cardboard pieces and you're going to trace them out. Now with the canoe, I'm going to put it right to the side of the cardboard to save me a little bit of cutting. And I'm just going to trace. I'm going to do the same thing for the robot. And you can stop videoing. Alright, so I traced my 2 shapes on my cardboard. Now I'm going to cut them out. This is kind of hard because it's cardboard, and if your scissors aren't really good, it might take you a little while. So just carefully cut out your shapes. Like I'm doing now. And you can stop. So now you're going to take your cardboard shape and put it in the center of your foil. And you're going to roll up your foil to make sides of the boat, just like I did here with the canoe. Now I gave you a little bit of foil. If you want to get some more foil from an adult in your house, if you have any extra and you want to make your sides bigger, you could do that. But this is what I did with my piece of foil. This is my canoe. And now I'm going to make my rowboat. Just by wrinkling up the foil and following my cardboard shape. You can stop. So what you've made for yourself are 2 boats that will look similar to this. Yours will be much smaller, though, because you had less tinfoil than me. And what I need you to do is get yourself some water, ask an adult, maybe you can fill the bathtub, or you can fill the sink, or you can fill something like this, and you're going to see how well they float. And then you're going to do some experiments to see which one maybe floats better. And which one can hold more marbles. So between now and science class next week, go ahead and test out your boats, and then we'll talk about it when we get together next week. Bye-bye.